Today we're going to talk about solutions to a system of linear equations. We'll start with the definition. When discussing two or more linear equations in the same group, we call that a system of equations. In our class, we're just going to focus on a system of equation that contains two linear equations. When you're graphing a system of equations, in our case we just have the two lines, these two lines are going to do one of three things. They're either going to intersect, they will be parallel, or it turns out that they will coincide, which means when you graph them, they graph the same line. So let's talk about another definition. The ordered pairs, or there could be one or multiple pairs, that satisfy both equations are called solutions. Now, if we have these two lines right here, remember we said one of three things is going to happen. If they intersect, how many points do they have in common? Just the one. If they're parallel and they never intersect, how many points do they have in common? None. And if they coincide, which means they graph the same line, how many points do they have in common? All of them. So if you'll notice, intersecting lines have 1 point in common, which means they have one solution. Parallel lines have no points in common, so we say they have no solution. And coinciding lines have all the same points in common, so we say they have infinitely many solutions. We call this type of system of equations dependent. Let's do an example. Let's find the solution or solutions to this system of equations, 2x plus y equals negative 2, 3x plus 4y equals 12, and we'll do it by graphing. So let's graph each line individually. Take a look at 2x plus y equals negative 2. We're going to graph that equation. The easiest way to graph is to put it into y equals mx plus b form. So get y by itself. Subtract 2x, and we have y equals negative 2x minus 2. Notice b equals negative 2, so that tells us our y-intercept is 0, negative 2. That's a point we know is on the graph. M is negative 2. Now we can write that as negative 2 over 1, which tells us we'll go down 2, right 1. Or we can write it as 2 over negative 1, and that tells us we'll go up 2, left 1. Now let's do the other line. 3x plus 4y equals 12. Solve for y. Subtract 3x from both sides. 4y equals negative 3x plus 12. And then we'll divide by each side by 4 to get y by itself. Now notice you're dividing this entire side by 4, which means you need to divide each of the pieces by 4. So we'll break that up into negative 3x over 4 plus 12 over 4 and reduce. Negative 3 over 4 does not simplify, but 12 over 4 does. So we have the linear equation y equals negative 3/4 x plus 3. Now notice b is equal to 3, so we know we have the ordered pair 0, 3 on the graph. That's the y-intercept. And the slope is negative 3/4. We can write that as negative 3 over 4, which means we would go down 3, right 4. Or we can write that as 3 over negative 4, which means you go up 3, left 4. So now that we have all that information, let's graph them. Remember that first line we said the y-intercept was 0, negative 2, and the slope was negative 2. So we could go down 2. Oh, where's my mouse? We could go down 2, right 1, down 2, right 1. Or we could go up 2, left 1, up 2, left 1. Get about 3, 4, 5 dots in a row and draw your straight line. Now the other line had the y-intercept 0, 3. And the slope was negative 3/4. We said we could go down 3, right 4, down 3, right 4. Or we could go up 3, left 4, up 3, left 4, and draw our straight line. Now what do you notice about these two lines? They are intersecting. Where are they intersecting? At this point right here, negative 4, 6. Now, so now that we know that our lines are intersecting and our solution is negative 4, 6, you can actually check if you wanted to. This should be a solution to both lines. So into each line individually, plug in x equals negative 4 and y equals 6 and make sure you get a true statement. Now there are two other systems of equations on your paper. Give those a try and we'll talk about those in class. See you then.